Good morning, everyone. I am Mrs. Padmashri from SNS College of Engineering, Coimbatore. Today, I am going to explain the concepts of shallow neural networks in the subject called deep learning. Let's move on to the slides. What is shallow neural network? Before we understand what is a shallow neural network, let me explain about what is a neural network. So neural network, basically it has a three layer. The first layer is considered as an input layer. The second one is a hidden layer, and the final layer is called the output layer. Okay, this is the neural network. So input layer receives the input and the processing has been done in the hidden layer and it sends the data to the output. Output layer produces the final result. So what is a shallow neural network? A network which has only one, or just we can say a few hidden layer between the input and the output layer is called a shallow neural network. This network is same as that of the neural network, but it has some additional features. These networks are very simpler, more easily trained, and have a greater computational efficiency than the deep neural network. So it performs mainly a simpler task, like we can say the examples in linear regression, binary classification, low dimensional feature extract. Shallow, shallow neural network contains small number of hidden layers, as I already explained. So how many hidden layers we can have is less than 4, 1 to 3 hidden layers we can have in the shallow neural network. And they are very much straightforward and it's mainly used to perform the task of data fitting, classification and pattern recognition. And it is mainly for fast training with very less number of parameters. Examples, as I already mentioned, from the machine learning, there are logistic regressions, SVM, random forest algorithm, cluster analysis. All these can be implemented by using the shallow neural networks. And this is the exact structure of the network where the input layer, which is represented in blue in color, is the input layer, and the center one, the purple color representation, is the hidden layer. You can see here hidden layers, and the last one, the pink one, which is called as a output layer. So from in through the input layer, we are receiving the input, and the processing has been done in the hidden layer, and the data is transmitted to the output layer. See, we can see here only one hidden layer is present between the input and the output. So we can say this is a shallow neural network. So it's a neural network, more than one hidden layer is no longer considered as a shallow neural network. So a neural network with two or three hidden layers with a small number of hidden units, simple connectivity, and it has a straightforward output is said to be a shallow network. Let me discuss some of the examples. This we have already studied in the machine learning subject, different types of algorithm. So shallow neural network example we are taking the same uh, algorithm, logistic regressions, support vector machine, random forest, and the cluster analysis. All these four can be considered as an example of shallow neural network. The structure. So the picture that we are seeing is a structure of a shallow neural network. Exactly it is going on. You can see uh, this is a shallow neural network. It gives the representation of what exactly is going on inside the deep neural network. So it is working based on the mathematical context. The figure we are seeing is having only one hidden layer and only one output layer, and you have three inputs of x1, x2, x3, and output we say it is a y cap. Let me explain about a simple neuron. So as we know the structure of neuron, a single neural network which has a number of neurons. When you take a single neuron, how it actually works. Neuron is the atomic unit of neural network, as we all already know, gives given as an input, it provides the output and passes that output as an input to another layer. So it is, we can say the a single neuron is a combination of two parts. Here we can say a circle is divided into two parts. So I am dividing a single neuron into two parts. First part is considered computes the output Z using the inputs and weight. Okay. Inputs are x1, x2, x3, and here for each input is associated with its own weight. So I'm taking it as w to the power t into x. X are the inputs and the weight associated with the inputs are w to the power t plus b. B is a bias value. The second part, which is having activation function on Z. Okay. So this the whole thing is considered as Z. W to the power t into x plus b is denoted, or we consider it as Z, and the second part is sigma of Z, okay, which is considered as A. So the output we are getting is A. The second part performs the activation on Z to give the final output A of the neuron. This is the single neuron structure. So let me explain what is happening in the hidden layer. So a neuron, as I explained the structure of a single neuron. This how a single neuron receives the input in the input layer. It processes it, the hidden layer, and sends the data to output layer. So what is happening in the hidden layer? It is comprising of various neurons. Not only one neuron, we will be having many neurons. Say for example, 1 to 3 hidden layers will be having many neurons, each of which performs the calculations about to calculation. So, see for example, I am taking 4 neurons and present in the hidden layer. Maybe we are taking as a shallow neural network. How the computation of Z will be, say W1, W2, W3, W4. So weight of the input X1, X2, X3, X4, and B bias 1, 2, 3, and you have the value A1, A2. Activation function is considered as A. What is this activation function called? Activation function checks whether the neurons are getting processed, whether the neurons are burned during the processing time. So if it is burnt means the neurons are burnt means it means the data are processed. The processing has been done in the neuron. Then the data will be transmitted to the output. A1, A2, A3, A4 is considered as the activation function. So a single neuron, since Z1 if I'm considering as one neuron, it is associated with this weight into the input plus bias and plus the activation function, which gives you the output called the sigma Z1 to the power 1. The same we compute for the all the 4 neurons. This is how the hidden layer is performing, and in the above equation that as I already mentioned, we have a subscript x1 to the power 1, and I was explaining that. So the superscript I denotes the layer number, subscript j denotes the neurons number, x is input vector which has the 3 features. We know that w is w of I and into J is the weight associated with the neuron J present in layer I. B of Ij is a bit bias function associated with neurons J, the layer I. Z of I into J, the intermediate output associated with the neuron J present in the layer I. And A is considered as a final output associated with the neuron J present in the layer I, and sigma is a sigma activation function mathematically represented as sigma of x is equal to 1 divided by 1 plus e power minus x. So these are all the various functionalities of the layers present in the shallow neural network. Thank you so much. We'll see in the next topic.